And in today's episode, among other things, you'll see a company that's trying to create synthetic humanoids for less than $20,000. We'll also see a new technology that's giving real muscles to robots, and that Elon Musk has joined Intel to enter a billion-dollar race to dominate AI chip production. In addition, we'll also see that a battery can now work for several months without needing to recharge. And robots have already started working inside real homes. Yeah, my friend, let's make sense of all this and a few other things about new technologies. Hello, impressed ladies and gentlemen. I'm Realidade Impressionante, and you're watching Realidade Impressionante. During a recent event in Silicon Valley, a statement drew a lot of attention. Not because of exaggeration, but because of the level of realism behind it. The possibility of creating synthetic humans on a large scale. The company Clone Robotics is proposing a completely different approach from what the world has gotten used to seeing in humanoid robots out there. Instead of motors, gears, and rigid structures, they are trying to replicate something much more complex: our own human body. While most of the industry builds machines that imitate the human form, Clone Robotics is trying to copy how our body works on the inside. The robot they developed doesn't use a traditional metal skeleton. It is based on a polymer structure that mimics human anatomy. And instead of electric motors, it uses artificial muscles called myofiber. This is a technology inspired by hydraulic systems that tries to reproduce the way our real muscles contract, relax, and generate movement. In practice, this creates a level of fluidity and precision that traditional robots simply can't achieve. But there's a pretty high technical cost behind this. Controlling this type of system is extremely complex, because each movement requires the simultaneous control of multiple variables, something much closer to biology than to classical engineering. And this is where artificial intelligence comes in. According to the company, the most advanced models are already able to abstract away this complexity, allowing the system to operate like this: arms, synthetic body, as if it were a conventional machine, but with much more natural movements. And the company's plans show that this is not just an isolated experiment. Together with their supporters, they have already set a very clear roadmap. As early as 2026, they may reach a level of precision that is enough to handle delicate tools. By 2027, the goal is to achieve a completely natural full-body gait. And in 2028, launch the first commercial robots focused on environments like hotels and corporate services. But the point that really changes everything here is the cost. According to the founders themselves, it is already possible to mass-produce these machines for less than $20,000. An amount that puts this kind of technology, let's say, dangerously within reach of the masses. And that completely changes the equation. When a technology nears that price, it stops being experimental. It starts to become something inevitable. But maybe the most uncomfortable part is yet to come. The company also revealed that it intends to evolve these models into versions that are increasingly human. First, they'll have neutral faces, and later, full facial expressions, replicating dozens of muscles that are responsible for micro-expressions. In other words, they want machines that not only move like us, human beings, but that actually look like a real human being. And when that level is reached, oh my friends, the difference between what is natural and what is artificial might simply disappear. And while you, or some others, look at this idea of synthetic humans and think it seems like something distant, almost theoretical, there's a technical detail that's making this possible right now, you know? Focus on this next report and you'll understand. Researchers from the MIT Media Lab, in partnership with the Polytechnic University of Bari, have developed a new type of artificial muscle that could redefine the way robots are built. Instead of rigid motors, gears, and heavy structures, they managed to create fibers that contract and expand in a much more natural way. And the most interesting thing is how this works. These fibers use an electrofluidic system, where the internal fluid is moved by a kind of microscopic pump. And by the way, it doesn't have any moving parts. In practice, this allows the system to operate silently while staying lightweight and extremely compact. Unlike traditional systems, which rely on hydraulic systems that are large and quite noisy in some cases, here everything happens inside the fiber itself, as if each muscle were a complete system. There's a detail that brings this technology even closer to biology. These fibers are organized in opposing pairs, where one contracts while the other expands, just like what happens with the real muscles in our body. And this creates a much more natural, more efficient, and highly adaptable movement. But the impact of this goes beyond engineering, because one of the biggest limitations of current robotics is precisely the way robots move. Traditional motors generate a rotational movement, which needs to be converted into linear movement. This creates structures that are, in many cases, heavy and have design limitations. With these artificial fibers, this problem simply disappears. In other words, the movement is already created in the right form. And this paves the way for lighter, more flexible machines that are much closer to human behavior. In addition, the system can be adjusted for different applications: more strength, more speed, or more precision. Everything is controlled through the internal pressure of these fibers. But even if the body of these machines is truly advanced or something like that, there is an invisible limit that defines how far all of this can go. And that's the processing power behind all these technologies. And if you think that the advancement of artificial intelligence depends only on software, you're mistaken. There's an invisible detail that is becoming the real limit of this evolution. These are the chips. And now, a huge move has just happened behind the scenes of this race. The all-powerful Intel has decided to join the ambitious Terafab project, led by Elon Musk. This will be an initiative valued at around $20 billion. The goal is not just to increase production, it's to completely redefine the scale. The plan is to build a megastructure in Texas capable of producing the equivalent of 1 terawatt per year. That's in computing power dedicated to artificial intelligence, a number that alone already surpasses the current industry standard. And this completely changes the way we see what's happening. Because this isn't just another chip factory. It's an attempt to anticipate a time when the demand for processing will really explode. And maybe no current supplier will be able to keep up with all of it. This project brings together companies that until recently operated independently. Tesla, SpaceX, xAI, and now Intel. These are part of the same ecosystem. This system gains something essential: real, large-scale manufacturing capability. The idea is to integrate different stages of production in a single place, combining logic, memory, and processing much more efficiently. This is something that completely breaks away from the traditional semiconductor industry model. But there's an even more aggressive point, which is the pace. While companies like NVIDIA and AMD work with development cycles close to 1 year, Elon Musk wants to reduce this time to about 9 months at most. And this would be an acceleration that could create a huge competitive advantage. But increasing computational power on a global scale creates a new problem that has accompanied all these technologies since the beginning. How are we going to power all of this? Is there enough energy? Let's find out in the next segment. And while new technologies try to make machines more efficient and even more human, there's another challenge that still limits all of this. It's energy. Because it doesn't matter how advanced a technology is if it depends on constant recharging. It will still have a limit. But now a different proposal is starting to appear on the horizon. A battery that doesn't need to be recharged the way you're used to. A startup called Avalanche Energy has just received a contract from DARPA to develop a new type of battery. A battery based on radioactive material. This one would be able to power, at first, a system the size of a laptop, but for several months without needing to recharge. This type of technology isn't completely new. It has already been used in space missions, like the robots that explore Mars, for example. But there has always been a problem: low efficiency. While traditional batteries can store large amounts of energy, the radioactive versions have always lagged far behind in this aspect. And that's exactly what this new project wants to solve. Their goal is to create a battery that is compact, durable, and with a much higher energy density than previous versions. And they intend to do this using a system called the alpha voltaic cell. In practice, these cells convert particles emitted by radioactive materials directly into electricity. Basically, it's similar to what a solar panel does with light. But here, instead of light, what generates energy are the invisible particles that are continuously released. And this completely changes the concept of portable energy. Because instead of storing energy, the battery starts to generate energy constantly. But there's a detail that's very important in all of this. This type of technology was designed for extreme environments: space, severe temperatures, intense radiation, places where conventional batteries simply wouldn't work. This, of course, shows the real goal behind this advancement. It's not just about improving our everyday devices. It's about enabling systems that need to operate for long periods without any human intervention. Satellites, military systems, space exploration, and even autonomous machines that need to operate for months without stopping. And when energy is no longer a limitation, these machines start to evolve in a different direction. Not just in capability, but in the way they interact with us human beings. And there's a technology that's already working in more than 180 countries, and that many Brazilians are already using. It's Nomad, and I'll be straight with you, okay? It helps you stop losing money. Nomad converts your money to the currency of the country you're in. Whether you're in Brazil or abroad, you open your account in just 5 minutes. You get the virtual card and then the physical one. You travel, shop online, or subscribe to services, bingo, without hidden fees and without any surprises at the end. And pay attention to this, okay? Nomad has launched its international eSIM chip, and you only activate it when you arrive at your destination. It works on Android and iOS, and it gives you internet access in more than 30 countries. And if you're Nomad PS level 1 to 4, you get 1 GB for free. Level 5, you get unlimited data for 15 days. And Nomad is giving $20 in cash back to new customers. But it's only for those who open an account right now using the code R20 on their first currency exchange transaction. Don't wait. Open your account using the link in the description, the pinned comment, or scan the QR code on your screen. Get your cash back now and stop spending way more than you need to. And of course, you also help Realidade Impressionante keep bringing you the cutting-edge technologies you always love to see here. Help me out and I'll help you, deal? Already known by viewers, what an old-fashioned word, here at Realidade Impressionante, Robotics has just taken a step that completely changes the interaction between humans and machines. They've created a system capable of recognizing, remembering, and even interpreting human emotions in real time. This system, called Vince, has already been implemented in a robot delivered to Ericsson. And what it does goes far beyond just responding to commands. It observes, analyzes, and learns from every interaction. Unlike traditional assistants, which treat each conversation as something isolated, this robot can recognize returning people, remember past interactions, and continue conversations exactly where they left off. It's as if they're creating a continuous memory inside themselves. And this completely changes the dynamic, because now it's no longer just a machine responding. It's a machine that follows along, that recognizes, and that adapts. What's most interesting is how this happens. The system uses cameras built directly into the robot's eyes, allowing the robot to maintain eye contact with you while it observes the environment around it. And this detail, which seems simple, is essential, because eye contact is one of the main elements. And when a machine starts to replicate this behavior, the perception changes completely. In addition, the system can interpret emotional signals, behavior patterns, and even a person's level of engagement during the interaction. In practice, the robot not only understands what you are saying, but also how you are reacting to everything that is happening. And this, of course, generates data. Each interaction is recorded, analyzed, and turned into information. Who are you? How do you choose? How do you behave? How do you react? And how does that change over time? And this opens up a completely new scenario, because these robots are not just interfaces. Now they are tools for real-time behavioral analysis. They can be used in customer service, in training, in marketing, and even in clinical applications. And when a machine really starts to observe, remember, and understand human behavior, we inevitably come to a profound question. What really defines the reality that we know? Let's discuss this in the next segment. Scientists at Brookhaven National Lab have observed for the first time particles emerging directly from what should be absolute emptiness. Yes, according to them, it's from nothing. The experiment was conducted inside one of the most advanced particle accelerators in the world, where protons are collided at extremely high energies. But what caught their attention wasn't the particles generated by the collision itself, but rather those that appeared outside of it. Particles that didn't come from the protons, but from the empty space itself. According to the most widely accepted theory in physics, the so-called vacuum isn't really empty. It is constantly active, with small fluctuations where particles appear and disappear in fractions of a second. But until now, this was just a theory. What the scientists managed to observe was something different. These particles didn't disappear. They became real, measurable with mass. The most impressive part is how this was identified. By analyzing the behavior of certain particles called hyperons, the researchers noticed a specific pattern in the alignment of their quantum properties. This pattern works like a signature, a kind of fingerprint that reveals where these particles came from. And in this case, everything pointed to an unexpected origin, the vacuum itself. This means that under certain conditions, Enough energy can turn these invisible fluctuations into real matter. And this raises a huge question. If particles can emerge from the void, then the concept of nothing might not exist in the way we imagine. And more than that, this discovery might help answer one of the biggest questions in physics. Where does the mass of particles come from? Let's save the complex stuff for later and check out the last interesting segment of the episode. And after all that, maybe the most important change isn't happening in laboratories or factories, but inside our own homes. In China, a new initiative has just brought robots directly into everyday life, in a way that until recently seemed distant, almost unlikely. X2 Robotics joined forces with the 58.com platform to launch a home service where humans and robots work together as a real team. And the way this works is simple, but at the same time very revealing. When a customer schedules a cleaning through the app, it's not just one person who arrives, but a pair. A human and a robot who will be working together, sharing the same job. The human is responsible for the more delicate tasks, those that require attention, judgment, and attention to detail. Meanwhile, the robot takes on the repetitive part, cleaning surfaces, organizing objects, and performing actions that follow patterns. And this turns each service into a real test for artificial intelligence. These robots use a system called a way, an embodied AI model that allows them to observe the environment, understand what is happening around them, and make decisions in real time, without relying only on pre-programmed commands. To rely only on pre-programmed commands. In practice, this means that the robot is not just performing tasks, it is learning while it works. And there is a detail that is strategic and completely changes the game. By operating within a platform that serves millions of homes, this technology gains access to a gigantic amount of real-world data. Each house, each interaction, each mistake, and each success becomes a learning experience. And this, of course, accelerates development exponentially. If you enjoyed this episode, go ahead and leave a like here. It really helps a lot. Make sure you're subscribed, okay? Thanks for staying with me. Choose one of the two suggestions on your screen, and I'll see you in the next one. Go ahead. I'll be waiting. I'm waiting. Come on, click it. All right? Bye-bye. I'll be waiting for you there. Come on, click it. Haven't you clicked yet? Come on.